So here's the problem that we did in class today. We're using Kb in this case, and we've got morphine, and I'm telling you in the problem that it's a naturally occurring base, and I've given you the Kb. So the question is, what is the pH of the resulting 0.0075 molar solution? So to solve this problem, this is basically what I'm going to write down on my paper first and foremost. Just getting the information for on the page. So always start with your equilibrium equation. I always like writing the Kb or the Ka for that equation off to the side. And then off in the top, I'm always going to write what my goal is. And sometimes in these problems, you're going to question how to get started, and just having that in the back of your mind is always a good thing as you get going. So for my initial concentrations here, for morphine, I'm going to write 0, and then for OH minus, I'm going to write approximately 0. And this is always just another reminder to myself that that autoionization reaction is going to be occurring in the background, just to keep that in mind. The change line here, minus x, and plus x for my OH minus concentration. Then I can go ahead and set up my equilibrium concentrations. So 0.0075 minus x, and x. Then I can set Kb equal to 1.6 times 10 to the minus 6th. That's going to equal x times x over 0.0075 minus x. And at this point I can solve for my x value. Now this minus x term here, this is going to be negligible. So we have done the test before where we take the initial concentration and we divide that by our Kb or our Ka. If that is over 100, then we can use that assumption, and we can say that this minus x term will be negligible. So let's go ahead and cross that out. If we solve for x in this case, we're going to end up with a value of should probably be prepared when I make these videos in the future. We're going to end up with a value of 1.1 times 10 to the minus 4th. And that is equal to the concentration of OH minus. This is a really common mistake here. People will forget that this is a Kb, right? And that we're solving for the concentration of OH minus when we solve for our x value. In class we said POH then will be equal to 3.96. And then we can solve for the pH, just 14 minus 3.96. That's going to give us 10.04. Or if we want to round this off properly, we'll just write 10 point as our final answer.